The next one is going to be the print method. So basically, I want to print, and for the printing, I'm going to use a different traverse algorithm to help us to do that. So my print method, I'm going to keep it very general. And so it's going to be, and it's going to call those algorithms. So first I'm going to implement a DFS, and I'm going to implement this DFS method basically in order way. So, and you can see it doesn't really matter. We're going to figure this out together very fast that we don't even have to call it a name. So I'm going to just call it the DFS here. And we can also add other methods that we implement a different way to implement them. Well, let's implement the DFS search or the DFS algorithm. So I'm going to keep it as a private because we're only going to use it inside this. So first I'm going to do the in order traverse of it, and then we're again see it's simple to convert that. And I'm going to do this in a recursive way. So we're going to write the recursive algorithm. So in order, we have to first go to the left, then middle, and then right, right? So here, this is what we're going to do. We have to start from root. There's no other way, right? So we're going to start from the root if the root is not empty. Then we keep going to all the lefts and all the rights, and we're going to keep recursively calling the same method. So we can also use helper method in this case because we need to start from the root. So our original DFS that's going to be called here, it's going to not need any parameter, and then we call another DFS and we're passing the root into it, right? So that way, we can even use this for in other scenarios as well, and to recur because we need that, right? So we need to go through all this recursion. So we need to have that. So that's going to be our helper methods, right? So we need that. So we're creating this water one that has a helper method in it. So it's accepting a root, or I'm just gonna, instead of roots, to not making it complicated, I'm gonna call it the current row, the current again, right? So we're passing root to it. That's our stopping point, kind of, right? So we're starting from there, and we keep going. When we're gonna stop? Now we're looking for a stop. So we stop when our current node is null, right? So this is if it's null, then I'm stop. Otherwise, I have to keep going, right? So that's a condition that keep me going. So that's the stopping point. So again, we do in order. So first, I have to do the left side. So what I'm going to do, I'm going to call the DFS again, and this time I'm going to pass the current dot left into it. So it's going to keep going all the lefts. Since we do in order, then it's going to have to do all the middles. And so that means I'm going to print the current node dot element. I'm going to print it out. And then it's going to call the DFS again, this time with the current dot right. 3 line of code, and it's going to do the magic for us, right? So otherwise, we're going to stop. And just on a, since we're printing this out, and we're going to have all of them in one line. So I'm just going to make it like this. So they're all going to be in one line with the space between them. So we print it in order way. I'm going to test it now. So I'm going to go ahead and create my test class. And the main method here. And so in the test class, we're going to create a my binary search tree of a type of string, for example. Let's do the example of the book first. So it's going to be integer object. So I'll call it and repeat that. So we're going to add stuff to it. So we're going to call the insert method. So what I just noticed that my root is not as accessible. So it has to be private. So we don't want that to be accessible. So we're going to make it private. So we're going to start adding elements to our basically to our binary search tree. So I'm going to add the same thing we did in the class example. We add 60. Then we're going to add the same example of the book. Next slide. Where is it? Okay, here. Okay, 60, 55. 100. So 60, 55, 100, 45, 57, 67, 107, 101, and the last one is the 9. Okay. So if you remember, in order when we're printing this out, so it has to, and also I'm going to also just test something. I am also going to add then another one, 101, to see if it's going to enter it for me, and I'm going to see what is going to be the result. I expect that to print out as false, and so it's not going to return. Let me insert this one, and also I'm going to do some search. I'm going to search for example, 107. That is actually the key available in this. It should be available, and then I'm going to do a negative one that's like 108. It is not available in this list. So we're just testing our search method, and also we're going to now print everything out. So I'm going to call the binary search tree. I'm going to call the print method. So now let's run this and see how things is going to work. Okay, let me see. Yeah, what? Oh, it adding a module. I need to remove this, so I don't need that. Okay, that should work now. Okay. So as we expect, it's going to insert everything, and then here when I'm I'm doing the trying to insert 107 again, it's gonna tell me false, and then I'm searching for 107 is returning true, and I'm searching for 108 is returning false because it's not in the list, and then I'm going to print it in order, so it's going to be what you see. I can easily go ahead and change that. Instead of in order, I can make it pre-order. So how we can do that? Very simple. So the pre-order, first we're printing the element, then we go to the left and right. So just have to switch their order. Now we're going to run it again. And you can see that this time is started from the root to print things out, and it's basically go all the way correctly. We had the example, exact same example, so you can check the results and see, but it's really going to go all the lefts, middle, all the lefts, and then all the rights for that one. So now if somebody asks me, okay, like how about, can you change it to post order? It's very simple. I can just go ahead and change this now, this time, left, right, and now last one is going to be the element. So I'm gonna run this again. Very simply, really very simple. It's just changing the order. Now I print everything in the post order. Now let's see how we can do that in a BFS, right? So BFS, I want to do level by level. I want to put this back and in order there, in order, right? So how we can do basically the BFS, right? So how we can implement the BFS method. So again, as I said, BFS can also happen recursively, or you can use a queue to implement that. So we can, that's going to be your exercise. So I don't want to do that for you, but it's not too hard to implement that. Really, you just have to need a queue structure, and you start adding element to your queue. And as you're adding element to your queue, basically you're going to also add to the end of the queue, you're adding their children. So, and then you visit them from the front of the queue one by one. So you see that everything is going to be work perfectly fine. So I'm going to demonstrate that using the whiteboard of the of this, but of the the whiteboard. But I'm not going to implement it. I'm going to let you guys implement it. But I'm also going to implement the we also need to implement the DFS using the what it's called as a stack. So that's also going to be another exercise, or want you to be able to do that one as well. So make sure you practice on those two. I guess in homework 7, I give you something like that. So you have to be able to implement that. BFS is going to be level by level, and in order to do that, every time that we not only need the the parents, the roots, right? So we also need the parents. So you can do these things in using a recursive method to implement the BFS. So BFS with recursion is going to be a little bit harder than the DFS. You have to think about what are the input parameters you really need in order to do that. Well, with the queue, it's easier to understand it. All right, so okay, now I let you guys to implement the BFS yourself in a recursive way. See what are the basically parameters you want and how you can make it recursive. So that's going to be a good exercise.